When you look up at the night sky, Sirius is the brightest point of light visible from Earth. But for all its brilliance, that light is hiding a secret. Modern astrophysics has proven that this bright blue star does not set alone. It has a tiny companion, a white dwarf known as Sirius B, locked in its gravitational pull and completely invisible to the naked human eye. Western science required the invention of high-powered modern optics to finally map the immense density and elliptical orbit of this hidden companion. Yet centuries before European telescopes confirmed its existence, the Dogon people of Mali had already mapped the Sirius system, maintaining complex, paperless archives detailing the exact nature of a star they could not see. The Dogon achieved this precise astronomical knowledge without a single glass lens or modern observatory. This level of empirical accuracy from a pre-industrial civilization upends the established timeline of when humanity first grasped the mechanics of the cosmos. The stage for these celestial calculations is the Bandiagra Escarpment, a rugged, isolated stretch of geography that served as a natural observatory. Rather than building towers reaching up toward the sky, Dogon astronomers used the Earth itself. They constructed specific dark chambers and dug deep earthen wells to isolate the night sky. This cross-section shows the technique. An observer at the bottom of a deep shaft blocks ambient glare, isolating a single beam of starlight. Because this shaft is a fixed focal point, as the Earth rotates, priests could track exact celestial alignments passing overhead for decades. These wells represent highly engineered, non-glass optical mechanics designed specifically for the collection of high-precision astronomical data. Observation is only the first step. Storing that data over centuries requires infrastructure. For the Dogon, that infrastructure was built into the cultural architecture of their villages. Their astronomical data was preserved through the Sigi ceremony, a massive cultural event triggered strictly by the orbital mechanics of the Sirius system. In this orbital model, we see a larger star, while a smaller body completes a tight elliptical orbit. The Sigi ceremony is held exactly once every 50 years, matching the orbital period of Sirius B around its larger twin. To ensure the math survived without written texts, Dogon astronomers encoded it into the Namo legends, creating the story of the Digitaria star to carry the specific celestial mechanics. The oral tradition describes Digitaria as the smallest star in the universe, yet the heaviest, so heavy that all the people on Earth couldn't lift it. This mythic description aligns with the actual gravitational properties of a super-dense white dwarf. By wrapping empirical measurements in vivid folklore, the Dogon utilized culture as a biological hard drive, ensuring complex data remained intact across countless generations. When anthropologists published the Dogon star maps in the mid-20th century, the findings directly challenged prevailing Western assumptions about pre-colonial African science. Skeptics proposed the theory of cultural diffusion, arguing that a wandering 19th century European astronomer must have visited Mali and taught the Dogon this math before anthropologists arrived. But as modern astrophysics advanced, that theory began to fracture. Deep space telemetry from late 20th century satellites continued to validate the measurements in the Dogon oral records. The definitive counter-evidence came from a third celestial body. Dogon lore predicted the existence of a star called Sirius C, a discovery that eluded Western astronomers until the late 1990s. The presence of Sirius C in Dogon records, a star unknown to Western science until the late 20th century, contradicts the theory that this knowledge was merely a recent European export. The elders wearing these masks serve as the active custodians of a sophisticated, independent scientific tradition that observed and measured the invisible universe. Their precise mapping of the Sirius system anchors the growing field of ethnoastronomy, providing concrete proof that the rigorous study of celestial mechanics is not an exclusively Western pursuit. Today, that ancestral data connects to the present. The historical intellectual rigor of the Dogon provides a foundation for modern African space programs and astrophysics education. How the Dogon made their very first contact with the orbital metrics of Sirius B remains a beautifully unresolved scientific enigma. But it leaves us with a compelling question. If a pre-industrial African civilization could map the invisible cosmos using dark wells and encoded mythology, we must wonder what other rigorous truths are hiding in the oral traditions of the world.